All right, so now we need to go the other direction. We need to go from, here I gave you the name, now write the chemical formula. All right, arguably this is probably the easier of the two. Okay, so if I'm dealing with an ionic compound, then I've got to do what you guys learned last year, which is, if I want to make the formula for an ionic compound, I've got to drop and swap, right? Okay, so I write out first the name of the formula for the metal. So let's say I was given, in this case, where I did that one. So let's look at, let's say I was given beryllium nitride. Okay, so let's say I was given that as a compound. So the first thing I do is write out the formula for beryllium, Be, and its charge, 2+. And then I write out the formula for nitride, N. And what's N's charge? -3. Okay, so I've got a +2 and a -3. Okay, so I'm just going to drop and swap them. So the 2 will come down here, the 3 will come down here. There's my new formula, Be3N2. And you'll notice that makes sure that the number of positives, 6, is equal to the number of negatives, 6. Okay, that's the whole reason for the drop and swap. It helps to balance all the positives and negatives in a compound. Okay, now there's only a couple of cases where this needs to be revised. Okay, and that is if you get numbers that can be what? They can be reduced, right? Okay, so if I was to get something that ended up being like a 2 and a 4, like let's say I had lead 4 sulfide, let's say. So let's say I was given this. Okay, so if I'm given lead 4 sulfide as a compound, I'm going to write lead. The Roman numeral tells me that I have to use which charge? The +4, right? That's, again, why we have the Roman numeral to help us get the right formula. And then sulfur is a -2. So when I drop and swap this, I'm going to get 2 and 4. Okay, but I can't leave it like that. I need to reduce it down to PbS2. All right. If you left it as 2 and 4, it's wrong. Okay, yeah. Always reduce it. If it can be reduced, you must reduce it for ionic compounds. Okay, what if you got a 2 and a 4 for a molecular compound? You leave it because the prefix is said that's what it is, and you leave it that way. Okay, but for ionic compounds, you always reduce. Okay. So you might just want to add that in. Okay, so basically all these steps here can be summarized into 3 words: swap and drop. Okay, that's what those are explaining. You guys already know how to do that. Okay, but then also reduce numbers whenever possible. Okay, really important that we remember to do that. Okay, is writing the formulas for molecular compounds even easier than this? Yeah, you don't have anything to think about for molecular compounds. You look at the prefixes and write the appropriate number. It's as simple as that. Okay, so like we said, for molecular, okay, write the formula for each element involved, read the prefixes, and put the right number in. Okay, so tetraphosphorus decaoxide, so P4O10. Okay, just put her down. Those ones should be pretty straightforward. All right. Oh, there we go. Okay. So what I need you guys to do right now is in the workbook, the digital workbook. How many people are? Okay. So if you go to Google Classroom and then go into the About tab, okay, and write down where the notes packages were. Okay. So below the notes packages, you'll see Science 10 worksheet package. Okay. No, you don't have to hand those in. We went over them. All right, so you can start right here, okay, on predicting formula for compounds, because that's what we just did. Okay, so they've got the names for you. You need to write, okay, the proper formulas for those. So in today's post, I will also post a document that is the key for these worksheets, so that if you're working on it at home and you want to know if you've done it right, you can just refer back to the key. So I will post that in today's lesson thing, so you can check back and forth. It is unfortunately a scanned version of my chicken scratch, but I think you'll be able to make it out. Okay, so if you need to put in a subscript, okay, that's the small numbers. So in this case here, we would go calcium, and then I would go up to format, and you can see that there's superscript, that puts it up top, like squared, okay, and subscript, which puts it down below, which is what we need. The shortcut key for that is Control, comma. So rather than having to click that each time, okay, I just go Control, comma, and you'll see, come here, Control, comma, okay, you'll see my cursor gets smaller because it's down below now, and then I just put the number in. It's small. I hit Control, comma again, and it gets back to normal size. Okay, then I can write in the phosphide. Okay, whatever, right? So it's like that. All right, so a question just came up on number 5. Do I still drop and swap if I'm dealing with a polyatomic ion? The answer is yes. Okay, so for number 5 here, we have potassium permanganate, so that's K plus 1. And then permanganate is MnO4, and it's a -1. Well, when I drop and swap, they just cancel each other off. KMnO4 is my final formula for that. A trickier one would be the one that had ammonium in it, which was 8. Yeah, ammonium sulfide, okay? Because ammonium is a weird one. It's actually positively charged. It's the only one on your chart that is, okay? So I write down ammonium. It's NH4, and it's a +1. And then I've got sulfide, which is a -2. So when I drop and swap this, I've got to put a 2 beside this 4. So what do I have to do to the ammonium? I've got to enclose it in brackets and put the 2 there. NH4S is my final formula for that one. Okay, so we treat them just like we would anything else. It's just that sometimes we have to put them in brackets. Okay, but they get dropped and swapped just like any other element would.